Good evening, sir.
Yeah, hello. Am I audible now? Pranav? Hello, Pranav. Am I audible?
Sir.
Okay. So earlier, I think I was not audible. Right now, am I audible to everyone? Okay. Harshit. Okay, so Harshit, Jitendra, Pranav, very good.
Yes, sir.
Very good.
You are on.
Okay, so very good evening. Let's continue now. So in the last class, we had, today we'll be doing, this is your, I think, chemistry class, right? Your first class, you have chemistry. Just let me share the screen. Uh, uh, uh. So today we have physics. Gravitation. So in physics, gravitation, we had done the topics which we had done over here were universal law of gravitation we had done. Yeah, Harshit and Jitendra, all of you just be active. Be active. Turn
Yes,
on
sir.
your camera, everyone. Keep your camera on. Jitendra. Jitendra, Harshit, keep your camera on.
So one second.
Your camera should be off during the class. It should be on. We have one more. So see here, according to the universal law of gravitation, we had seen that the force acting on a body so is directly proportional to the product of the masses m1 multiply m2, and this force is inversely proportional as the square of the distance. So we had seen how these variations occur. If the product of the masses is doubled, then the force also becomes double. If the product of the masses becomes 4 times, then the force also becomes 4 times. Okay, if the product of the masses becomes 1/3, so the force also reduces to 1/3. One thing we need to understand about the gravitation, a very, very important point is that this force so according to gravitation, the first point is that it is always between it is always attractive in nature. So the force of gravitation, it is always attractive in nature. It can never repel each other. And the second point about the gravitation is that it is or it acts between all masses in universe. All masses in universe. So wherever you have a mass over there, you will have the force of attraction between two bodies. So for example, on the earth also, if you have two people standing, so I can say that the two people, they are attracting each other. Any two bodies, okay, it can be even two, let us say a proton and an electron. So they also have the gravitational forces of attraction between them. Right? So the gravitational forces of attraction are there between all the bodies in this universe. It's not only about the earth and the moon. It's not only about the earth and the sun. As we see that in the case of sun and earth system, the force of gravitation is there, which makes the earth revolve around the sun. Okay? So the force of gravitation makes the earth revolve around the sun. Okay. It holds, we can say that the sun is holding the earth with the force of gravitation. It's attracting. Everywhere, even a small mass will have a force of gravitation with each other. So, if we say that earth has some gravity or earth is attracting all the objects towards itself, like I can say about gravity, so it is the force with which earth attract all the objects towards itself. Okay. So it is like if you throw a ball upward, if you throw a ball vertically upward, so earth attracts that ball towards itself. Okay. And that is because of the force of gravity. The earth attracts the moon towards itself. That is also because of the gravity. Okay. So in this way, the gravity of the earth is responsible for attracting different objects. It is the gravity of the earth that you can't jump and fly off in the sky. That is the gravity of the earth is pulling it down. It is the gravity of the earth which pulls the fruits down. If a fruit falls off from the tree, so it falls down because of gravity. Got it? Harshit,
Yes, sir.
why your camera went off? You have to be there.
Sorry, sir.
Every time I should say to everyone. Shravan, Shravan,
Yes, sir.
keep your camera on.
Okay, sir. One second.
Now it's mandatory to keep the camera on. Mandatory. It's not optional. And it should always be on. Okay. So Shravan, what is gravity?
So it is a force which attract all the object towards itself.
Which attract all the objects towards itself.
To the earth.
Earth. Okay, it is the
Yeah.
force with which the earth attracts all the objects towards itself that we call as the gravity. Okay. And what is gravitation here? What is the force of gravitation that we have studied here? Yeah, Shravan, what is the force of gravitation?
So I just joined the class. I don't know.
Okay, so the force of gravitation, it is the force which is always attractive in nature. Okay, so first of all, the gravitational force, it is always attractive in nature and it acts between all the masses in universe. So every mass in the universe, you can collectively call gravitation to be like every mass in the universe attract every other body with a force. Okay, that we call as the gravitational force. So the same gravitation which we have understood here with the 2 points, we can state gravitation to be like this. We can say that gravitation, it is the force of attraction between any two bodies. So it is the force of attraction between any two bodies in the universe. Where we have covered both the statements which we have stated for the gravitation. So first of all, the gravitation, it is always attractive in nature and it acts between any two bodies. So can I say that Harshit and I, we are experiencing a force of gravitation due to each other. We are being attracted towards each other. Can we say like that?
Yes, sir.
Yes. Because we two are two bodies, we two are masses. Okay. And we are separated by some distance. So definitely there is a force of gravitation between us. Okay. So this force of gravitation always exists between two bodies. Now, how to measure this force? So this force is measured according to the universal law of gravitation. So now I will state this universal law of gravitation. The statement for universal law of gravitation is important. It has been asked in examinations. So on almost all the exams, you will see universal law of gravitation. So universal law of gravitation, it states that the force between it states that the force between any two bodies in the universe is directly proportional to the product of the masses is directly proportional to the product of the masses and inversely proportional to the square of distance between them. So just go through this universal law of gravitation. According to the universal law of gravitation, it states that the force of gravitation between any two bodies in the universe Because the force of gravitation between any two bodies in the universe is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, I'll tell you a few more points regarding this. So a few more points like this statement is a complete that it states that the force of gravitation between any two bodies in the universe is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. It also states that it acts along the line joining the two masses. Okay, so it acts along the line joining the two masses. What are the two masses? How it acts? Let us see. So we consider here two masses. Let's say you have a mass m1 here, another mass m2 here. Okay. So let this be your mass m1 and this one be the mass m2. So you have the masses m1 and m2 joined by, they have some distance. So their centers are joined, separated by some distance r. So their centers separated by some distance r. The gravitational force acting between them will be given as gravitational force F will be equal to, or it will be proportional to this. The gravitational force will be proportional to the product of masses m1 multiplied by m2, and it will be inversely proportional to the square of the distance between them. So this point we had also seen in our previous classes. Is everyone able to recall up to here? Sharwan?
Yes, sir.
Okay. So are you able to recall now? Just go through the universal law statement. I will ask this statement everyone. Harshit,
Okay, sir.
Yes, sir.
Harshit, can you state the universal law of gravitation?
So it states that gravitational force between any two bodies in the universe is directly proportional to the mass of both the objects by the
No,
distance square. And
no. Just read it first. Read it again.
product of
Read
the
it and then
masses and inversely proportional to the square of distance
first,
with.
first read it on your own and then speak up. First read the complete statement and then speak up. Okay. Sharwan?
Yes, sir.
Okay, read the statement and then speak up.
Okay, sir.
Okay, so Harshit, can you speak up the statement now for the universal law of gravitation?
It states that the gravitational force between any two bodies in the universe is directly proportional to the product of the masses of both the objects and inversely proportional to the square of the distance between them.
Yes, it is inversely proportional to the square of the distance between them, and it is proportional to the product of the masses. So here the you can remember it as a shortcut with these two. See, the symbol is read as proportionality. So we read it. Force between the two bodies is directly proportional to product of masses, that is m1 multiply m2. It is force is proportional to m1 multiply m2, that is product of the masses, and it is inversely proportional to square of distance between them from the second one. Okay, so you can combine these two statements and write it right from here only, that the gravitational force between any two masses in the universe is directly proportional to the product of masses and inversely proportional to the square of the distance between them. Sharwan, can you tell the statement now?
Okay, sir. force of gravitation between two bodies in the universe is directly proportional to the product of the mass and inversely proportional to the
Mhm. Inversely proportional
to the square of distance between.
yeah, inversely proportional to the square of the distance between them. So the force between any two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Also, it acts along the line joining the two masses. So the line joining the centers of the two masses is this one. So the force between them, it also acts along the same line. Got it? So by combining these two factors, I can write here F proportional to, I can write F proportional to M1, M2 divided by R squared. Yeah, this is what the proportionality results out. Then by removing this proportionality, we introduce a constant which we call as universal gravitational constant. So we can rewrite this as F equals to a constant G multiplied with M1, M2 over R squared. Understood? We have removed the proportionality and we got this as F which equals to the constant G multiplied with M1, M2 over R squared. Right? So we shall. Okay, Pranav, can you tell the statement now again? Pranav? Pranav, can you tell the statement? Pranav, can you tell the statement? Unmute yourself and tell. Pranav? Pranav, you are not audible. Pranav, you are not audible. Okay, Jitendra,
Yes, sir.
okay, can you tell?
Yes, sir. The force of gravitation is directly proportional to the product of masses, and the force of gravitation is inversely proportional to the square of distance between them.
Yes. So the G here we have introduced as the constant. This G is called as universal gravitational constant. So what do you mean by universal? Yes, what do you mean by universal? When we say universal,
Sir, it is same everywhere.
it's same everywhere in this universe. Everywhere applied in this universe, it can be applied. Either on moon or on sun or on a black hole, wherever you go in this universe. So everywhere in the universe, it should be applied. So universal gravitational constant, it is applicable everywhere. Okay, that we call as the universal law of gravitation. Okay, so universal gravitational constant G, it is applicable everywhere. The value of this universal gravitational constant is obtained from the same statement by some experimental techniques. It has been obtained. The value of the universal gravitational constant. Let's see, let us obtain the value of the universal gravitational constant. Okay. So, Shravan, what is the symbol for universal gravitational constant? Which symbol did we use for universal gravitational constant?
G.
G, it's capital letter G. Okay.
Yeah,
It is
can.
denoted by a capital letter G, that is universal gravitational constant. You should
So
not
it's
remember
-10, right? -10.
how much.
-10.
It's not -10. Okay, you are
Sir, it is 6.67 into 10 power minus 11.
okay. It's 6.67 into 10 to the power -7 or -11. What it is? 6.67
Minus
multiplied
11, sir.
-11, and its units are Newton meter square per kilogram square. Okay, so see, per kilogram square it is written as kilogram to the power -2. So how can we write this unit as per kilogram square? How did we obtain this unit? See, how we obtain the unit? The unit is obtained from the formula itself. Okay, we write the formula here. See, F equals to G multiply M1 M2 over R squared. So we will obtain we want to obtain the units of G. We transpose everything to the other side. We get F multiplied with R squared divided by M1 M2 equals to G. So from here we obtain the units. The force is measured in Newton. So at the place of F we write here N. So it is Newton. R is measured in meter. So we write it meter. It's a square, so meter square divided by M1, M2. So M1 is the mass which is measured in kilogram. Okay. And this M2 is also kilogram. So kilogram multiply kilogram is kilogram square. Okay. This is the unit of G. Now you can write the same thing in this way. Newton meter square kilogram -2. Sharwan, did you get it?
Yes, sir.
Okay. So Shravan, what is the value of this universal gravitational constant?
So 6.67 into 10 minus power raised to
Okay.
11.
Okay. So just a quick question here. A quick question. Let's see if you are able to solve this on the basis of the formula. You have the formula also here. You have everything over here. So just let me see if you are able to find it out. Everyone just. So what will be the force of attraction between two bodies in the universe of mass 1 kilogram and separated by a distance of 1 meter? Yeah, to find it out, what will be the force of attraction between two bodies in the universe of mass 1 kilogram each and separated by a distance of 1 meter? Everyone, just try to answer this. It should not take more than a minute. The formula is given to you. You know the constant, you know everything. How much is the answer? Harshit,
Sir, doing one.
okay, don't become Mr. India. Yeah. Anyone got the answer? Sharman, what is the answer?
I didn't
Sir,
get
is
the
it
answer.
sir, is it 6.67 into 10 power minus 11?
Okay, just let me see. Sharman, what is your answer?
Sir, I didn't write any answer.
You didn't get the answer. Okay, which
No.
formula are you trying to use?
So the F equal to G into M1 M2 by R square.
Okay, so what is the value of M1?
Sir, 1
What is the value of M2?
1
What is the value of R?
at
Yeah, what's the value of R?
R
R is not the radius. Okay, R is not the radius. R is the distance.
okay, so it's 1.
1. Okay. So use everything in the formula. M1 1, M2 1, R as 1. So what do you get the value of F now?
1.
Yeah, how much, Sharwan?
So 1.
1. Okay, just let's see here. So from this question, we obtain F equals to G M1 M2 over R square. G M1 M2 over R square. So the value of this I write as F equals to the value of G is 6.67. So I write here 6.67 multiply 10 to the power minus 11. I'm just putting all the values. M1 is 1, multiply M2 is 1, divide by R which is 1. So you get R squared which is 1 squared and 1 square is 1. Okay. So Sharon, now can you tell the answer?
So now should we multiply 6.67 into 10?
Yeah, so you can write it in the same way. You can write it in the scientific order. You
Okay.
don't need
So
to
the
write into
answer
the
is the answer 6.67 into 10 raised to the power 11.
negative 11.
Negative 11.
Yeah, Newton. The answer is in Newton. So this will be the force between them. Okay. Just try this one also. Try the same thing. A similar question here. What is the force of attraction? What is the force between two bodies of mass 1 kilogram each, separated by a distance of 1 centimeter? Okay, now solve this. They are separated by a distance of 1 centimeter. So what will be the force between them?
So should we convert centimeter to meter
Yes,
something?
yes, we need to convert centimeter to meter. Everywhere we'll be using SI system of units. Okay, anyone got the answer? Harshit, did you get the answer? Harshit,
So, one second. So, actually, can you turn the page back once? I was noting.
okay, you want the formula?
Yes, sir. Actually, once can.
Okay, I'm giving the formula here only. The formula is F equals,
Sir,
Mhm.
mass means it is kg only, right?
yeah, mass is in kg only. So
Sir,
this is the
actually, will
formula.
it be 6.67 into 10 power minus 11
6.67 into 10 to the power
minus 11?
minus 11, that is the value of G.
Sir, actually, I think it's the value of answer also because 1 into
No.
1 equals to 1 by 1 square 1.
But
So,
this one is in centimeter.
oh,
Convert it to meter.
So it's 1 by 100. So I got as 6.67 into 10 minus raised to 11 by 100.
6.67 into 10 to the power.
Minus 11 by 100.
No, not by 100.
minus 10,000.
Minus 10,000.
Sir, we will get the answer as 6.67 into 10 power minus 50.
Okay, see. I tell you a very easy method to convert. Okay. I think you people are using those traditional methods of conversion. Don't use those traditional methods. Use this method. If you have to convert 1 centimeter to meter, multiply that number by 10 to the power minus 2. You'll get converted to meter. So you can remember 1 centimeter is 10 to the power minus 2 meter. Okay. And in the similar way, if you have 1 millimeter, so 1 millimeter will be equal to 10 to the power minus 3 meter. Okay. So just remember it this way. A centi means 10 to the power minus 3. Milli means 10 to the power minus 3. A micro, if you have somewhere a micrometer, so a micro means 10 to the power minus 6. So these words have a meaning. Centi means 10 to the power minus 2. Milli means 10 to the power minus 3. Micro means 10 to the power minus 6. Okay. Now see how your calculation becomes easier. So we have converted this 1 centimeter. 1 centimeter is 10 to the power minus 2 meter. So we use this formula F equals to G, which is 6.67 multiply 10 to the power minus 11, multiply M1, which is 1, multiply M2, which is 1. This whole divided by R squared. Your R is 10 to the 10 to the power minus 2, or you can write it as 1 multiply 10 to the power minus 2. Right? So we write it as 1 multiply 10 to the power minus 2 square. Like if it were 2 centimeters, so we would have 2 multiplied 10 to the power minus 2. Okay. So you get this. Now you solve this one. You get 6.67 multiplied 10 to the power minus 11 over, it is 1 squared multiplied 10 to the power minus 4. A power of power means the multiply of the powers. Okay. So you get here 10 to the power minus 4 and not 2. Now you can easily solve this. You can take this 10 to the power minus 4 in the numerator. It will become 10 to the power plus 4. So you get 6.67 multiplied 10 to the power minus 11 plus 4. This divided by 1, it remains the same. Got this, everyone? Sharwan, did you get it?
Yes, sir.
Actually, one step I haven't written over here. The one step that I should write is I should write this. So I should get here multiply 10 to the power 4. It was 10 to the power minus 4 in the denominator. So when taken to the numerator, it becomes 10 to the power plus 4. And now you get 6.67 multiply 10 to the power minus 11 plus 6. Bases are same, so power will be added, minus 11 plus 4. So it makes 6.67 multiply 10 to the power. You have a negative 7 Newton. Got it? Always write the units. Got this answer? So let's do one more answer. Let's do one more question here. So you have to write what will be force of attraction between Earth and a mass of 1 kilogram. Given mass of Earth and the radius of Earth. So you are given the mass of Earth and radius of Earth, something like this. The mass of Earth m as 6 multiplied 10 to the power 24 kilogram, and the radius of the Earth r as 6,400 kilometers. Just think of mass of 1 kilogram, let's see, at the surface of Earth. Okay, so try to find it. Okay, anyone got the answer now?
We're doing one
Tell.
second.
Yeah, who else who else have obtained the answers?
Sir, actually, you can once give the formula. I am getting the wrong answer.
What you are getting?
Answer something more than 10.
More than 10.
Yes, sir.
Okay. Sharwan, are you getting the
So,
answer?
I got like 6.67 into 10, 10 raised to minus 11 into 6 into 10 raised to 24 by 6,400.
Okay, first of all, see, this is 6,400 kilometer. This is 6,400 kilometer. So convert it to meter.
So 6,400 into 1,000.
Yeah, it will become 6,400 into 1,000 meter. So you can write it in scientific notation. You can write it as 6.4,
6.4 into 10 power 5 meter.
10 to the power 3, 6.
So 6, 5. Okay, 6.
6. It's 6.4 multiplied 10 to the power 6. There are 3 zeros here. And if you write 6.4, so you count the digits from here. You get 3 digits. Okay. So convert it in SI unit. This is meter. Now obtain your answer. F equals to G M1 M2 over R squared. Just put the values everywhere. Sharon, put the values and solve it.
Okay.
Yeah, so see, you should be getting this as 6.67 multiply 10 to the power minus 11 multiply M1, which is 6 multiply 10 to the power 24 multiply M2, which is 1, divided by the distance. So see, the object is lying on the surface. Okay. So the distance of the surface from the center will be equal to the radius itself. So you get this as 6.4 multiply 10 to the power 6 whole squared. You see? You get 6.67 multiply 10 to the power minus 11 plus 24 and multiply 6. The denominator is 6.4 square multiply 10 to the power 12. Sharon, did you get this?
Also,
Just check everything. Did you get the same?
no.
No. Where it was different? The denominator or the numerator?
So the numerator, I
The
didn't
numerator.
I didn't plus the powers.
Okay. So whenever it just see, whenever the powers of 10, you have here a power of 10, you have here a power of 10. Okay, the bases are same. So powers can be added. This is negative 12, 11, this is positive 12. So you add the powers. Got it? Now, what is left here? You'll be left with 6.67 multiply 6 divided by, you have 6.4 squared. So square this 6.4 and see what do you get? What is the square of 6.4? Yeah, what is the square of 6.4? What is the square of 6.4?
Sir, it's 4496. 4.96.
Is 40.96. 4096, obtain it 2 decimals, you get 40.96 multiply 10 to the power 12. In the numerator here you have multiply 10 to the power plus 24 minus 11. So if you add 24 and minus 11, you get here 13. Am I correct? 13 or what? Yes, we get 13.
Yes.
Now you take this 10 to the power 12 to the numerator. You take this 10 to the power 12 to the numerator. What do you get here? you get 6.67 multiply 6. Multiply this one also. Multiply, okay. If you find the numbers to be long, you can take it 6.7. Okay, instead of taking 6.67, you can take it 6.7 also. So take it 6.7, multiply it with 6. Okay. And here you have 40.96. Take this 10 to the power 12 upward, you get here multiply 10 to the power 13 minus 12. So see how we reduce such a big number to a small number. If you multiply 6.7 with 6, you get 40.2. So this you get as 40.2 divided by 40.96. And here you get multiply 10. So you can consider as 402 divided by 40.96. Okay. Now you can divide this 402 by 40.96, and as a simplicity, just to remove your such a big calculation, you see it's 40.9, so you can take it 41. You can take 402 divided by 41. Okay, divide it and see you get something 9 point something. Round it off here. I've rounded it off. So I divide 40.2, sorry, 402 with 41. Okay. So this you get as 9.80 Newton. Got it, Sharwan?
Yes, sir.
Okay. So in the coming class, we'll practice more questions on this. All right. Okay. Okay. Bye, all of you. See you again in next class.
Thank you, sir. Bye.
One second.